Have you ever wanted to connect your Arduino to the internet? Your first thought was probably like, okay, I guess I'll need some type of Wi-Fi shield or a Wi-Fi enabled board in order to connect to the internet. But what if you're building something that's more of a desktop project? That is, you fully anticipate that it's going to be sitting right next to your computer. And if you want this thing to have internet access, does it really have to connect over Wi-Fi? So then your next thought might be, well, if it's not going to be Wi-Fi, I probably need to get an Ethernet shield or something like that so I can connect my Arduino directly into the Ethernet. But there is another option that doesn't require Wi-Fi or Ethernet. It's just connecting your Arduino via USB to your computer, assuming that your computer's connected to the internet. What you're able to do is use the Arduino serial library to communicate with an application on your computer that manages your internet requests. So if you go this route, all you need is an Arduino board and a USB cable, and you can connect to the internet. No other hardware needed. All you have to do is install some open source software called Processing and write a small program to grab the information that you want from the internet. Now, what we're going to do in this lesson is walk through that process from start to finish. So by the time you're done here, you will be able to get information from the internet down to your Arduino board over a USB connection to your computer. Now, to demonstrate getting some information off the internet, we need some type of example. So what I've set up and what we'll demonstrate in this lesson is grabbing some space weather forecast information from the NOAA website. That's the National Oceanic and Atmospheric Administration website. So our program is going to grab some information. It's going to be called the Planetary K-index. It's a measure of the magnitude of geomagnetic storms. It's just a number. It's a number from 0 to 9. We're going to grab the current forecasted number from the internet, and then we're going to pass that number down to our Arduino board. And then our Arduino is going to light up a number of LEDs based on that number. So if the KP forecast is 5, then we're going to light up 5 LEDs. If it's 8, we'll light up 8 LEDs. I think you get the idea. So by the time we're done here, we're going to have a super simple space weather forecast widget sitting next to your computer. All right, let's get started. Subscribe to our YouTube channel to get more videos like this. Before we start, just a big shout out to Altium for sponsoring this video. Huge thanks. You can check the description to get a free trial of the Altium software. All right, so this is what we're going to do. We want a computer program on our computer to grab specific data from the internet and then pass that data over the USB cable to our attached Arduino board. And then we want our Arduino board to be running a program that keeps an eye out for incoming serial data. And when it gets that data, we're going to have it do something with it. And in this case, we're going to light up some LEDs. So that sounds like a lot, but thanks to open source libraries, it's not going to be all that crazy. Now, when I'm working on a project like this, there's two principles I like to keep close to my heart. The first one is I always like to start with just a simple plan. The second thing is I always like to look for code examples to kind of get me started. So first, let's go ahead and write out a simple plan of what we need to do. I want to connect to the internet with some program on my computer. I want to send data from that program to my Arduino. I want to have my Arduino read in data from that program. And then I want to light up some LEDs on my Arduino based on that data. The first thing I'm going to try and figure out is how to write a program that sits on my computer and sends data to my Arduino. So what I'm going to do is use a programming language called Processing to do this. Now, you can download Processing for free. It's open source software just like the Arduino. So I'm going to go ahead and download the Processing. What we're downloading here is an IDE, so an integrated development environment. So when you download Arduino and you install it, same idea. You're downloading and installing an IDE, and what I'm doing is downloading and installing the Processing IDE. So it's really simple to download and install. Do you need a printed circuit board design software to move your prototype to the next level? Altium Designer is a great choice for designing PCBs sharing your design with team members, and even getting your design manufactured. What really kind of blows me away about this software is that even though it's a super powerful tool, at the same time, it's really intuitive to use. They've got helpful video tutorials built right into the software so you can kickstart your learning process and actually get something made. Right now, you can get a free trial to Altium Designer with our link in the description. That's right, you can test drive this super powerful software with a free trial. Just check out the link in the description. Now, when you open up processing, you are going to notice that it looks a lot like the Arduino IDE. And that's because the Arduino IDE was actually based on the Processing IDE. All right, so here we are in the Processing IDE, and what I want to do is open up an example sketch. So if you go up to File and you go to Examples, they've got a bunch of different examples in here, and the one we're going to use is from their serial library. Here it is right here. And you can play around with any of these, but we're going to play around with the simple write. I just want to write a program in here. I want to use a program in here that's going to send a piece of data to my Arduino. So let me click on this. And here is this sketch right here. So what's cool about this sketch is that not only does it have the processing code in here that's going to run on the computer, but it also has the code that runs on the Arduino. So what I'm going to do is I'm going to copy this code right here, and I'm going to paste it in my Arduino IDE. I'll get rid of these comments here, do some formatting. Now on my Arduino, I'm going to have an LED attached to pin 6, so I'm just going to change that, but otherwise it should be the same. I'll make sure to save this. And then I'm going to make sure my Arduino board is connected. So Arduino Uno, yep, there it is, the port. All right, COM3 Arduino Uno. I just want to take note of that. All right, COM3 Arduino Uno. And let me just upload the sketch to my Arduino. Now I'm using the kit on a shield on top of my Arduino, so I don't actually have I don't have a breadboard wiring up the LED. I've just got the kit on a shield there, but it's just going to have an LED at pin 6. And all this sketch is doing is it sets the mode of the pin as an output. So pin 6 is going to be an output. Start serial communication using a baud rate of 9600. And then down in the loop, it's got a while loop inside the loop. And it says, hey, if anything's available in the serial buffer, then we want to read that value. So serial.available is going to return either true or false based on whether or not there's information in the buffer. So if it's true, read the value from the serial buffer and store it in a variable called val. And that value is either going to be an H or it won't be anything. If it's an H, if you get a value, then the LED is going to turn on. We'll do digital write high, so we'll turn the LED on. Otherwise, we're just going to turn the LED off, and then there's going to be a delay of 100 milliseconds. That's it. So right here, this line 14 is what's looking for data coming into the serial buffer. This is what's allowing the Arduino to sit there and wait for information to come in and respond when information does come in. All right, so let's take note of that. So it was COM3 is the port we're using, and we've already got the Arduino. They gave us the sketch to set it up to look for information coming to the serial port. Now we're going to come over to this processing sketch. Now, I'm not trying to, this isn't going to be a lesson on teaching you all the ins and outs of processing because, one, I couldn't do it. I don't know processing all that well, but I know it enough to kind of be dangerous. So let's just start at the top here. Basically, what the sketch is doing is it's importing the serial library from processing, and then it creates a serial object. This serial object is what allows processing to talk to the Arduino, okay? Now, in this case, we are calling the serial object myPort. So that's what they're using here, myPort. Now, I like to call it like Arduino, but you can call it myPort, it doesn't really matter. Now, they've also got another integer called val here. I'm not sure we're actually going to use that in here. Are we using val? No, I don't even think they use val in this program, but I think that's a carryover from another example they have. All right, so processing, just like Arduino, has two very important functions. So one is called setup, just like Arduino setup. It runs once. And then the other one is called draw. So draw is to processing what loop is to Arduino. So processing is a visual arts software. Like the idea is that you use this software to make like these visual like graphics, I guess is the way to put it, or interactions. I don't know. It's really pretty cool. I've played around with it a bit. It's been a while, but it's super fun to work with. Anyhow, what happens is every time you hit this play button, a little app opens up on the computer, and like there's a little window that opens up. Here, I'll just hit play here real quick here, and you'll see this little window pop up. You'll see this little window. This is like where stuff happens, right? Inside your app. So like visual stuff would happen here, but the size of that window is determined by the size function. So that's what this size is doing. Now, this is where we're interested down here, line 21 and 22. All right, so this is probably going to be the toughest part of this entire thing, right? Because it's just a little bit confusing. So we use this function called serial.list, all right? Serial list is going to return an array. So an array is just a list of things. In this case, it's going to return an array of all the serial ports on your computer. So there's going to be a list starting at 1 or starting at 0, going down to whatever of all the serial ports. Now, right now we have 0 selected, okay? So this is saying whatever the first element in this serial list array is, we are going to set it equal to port name, okay? So basically the port we want to associate with this serial object up here, we are saying it's the first element in this array, but we don't know that yet, right? Like this is just kind of a default setting. So what we need to do though, to figure out which serial port our Arduino is attached to on this list is we actually have to print this out to kind of get an idea of where it is. So I'm going to use the print array function to print off the list of serial ports. So let me do that. All right, so now when I hit play, down here, I should see a list of all the serial ports attached to my computer. So here, there is only one serial port. It's COM3, so that's the Arduino I have attached. Now, you might be like, wow, why did you go through the trouble of printing it off? On most computers, or at least on other computers I've used, there's a huge list of different ports available, right? This one happens to be at 0. Okay, so this is going to work. I'll just set this to 0, and that should work fine. But if it's not, let's say there was like a COM1, a COM2, a COM20, whatever, wherever COM3 was, whatever value in that associated array, that's what I would want to set line 22 equal to, if that makes sense. All right, so this line 21, we've got a string, we're calling it port name, and we're setting it equal to the 0th element in this list of serial ports. Right now, there's only one serial port in the list, so it's going to be set at 0. All right, then what we do is we initialize that serial object, all right? And it takes 3 parameters. This port name, which is the name of the port, right? So you got to put the port that we're going to have it look at or send to right there, and then the baud rate. So that's got to match up. Whatever you're using in your Arduino IDE, you need to use here. So we're going to be using 9600 as the baud. So I know this syntax is a little bit different. We're using it's like the serial constructor to create a new serial object. So that's a little weird, but you know, if you just kind of use the example code, it kind of draws it out there. So what this is going to do, and this isn't too important. I think the most important thing I want to focus on here, down here, is what is this line of code right here, where it says myPort.write. If we want to send something serially over to the Arduino, to the serial port that the Arduino is monitoring, we use the .write function. So myPort.write, again, myPort is a serial object that we created up here, right? So myPort is a serial object. And so when we say myPort.write, write is a function of that serial object. And so whatever we write here, that's what's going to get sent over. Now in this case, what happens is, let me go ahead and hit play here, is this opens up a little square. So with this program, when my mouse is over the square changes color and it sends an H to the Arduino. And so when the Arduino gets the H, it turns on the LED. And then when I'm off the square, it sends an L, and then that tells the Arduino, hey, don't write anything. So you can turn the LED on and off, you know, like this, which is kind of fun to do. Really simple, you know what I mean? But again, the basic concept here is we need to use this myPort.write. Okay. So again, this is just waiting. Here we are in the Arduino IDE. We're waiting for some information. Once it comes in, we check, hey, what is the information? Based on the information, we do something. In this case, we're turning an LED on or off. Okay, so now we're armed with this basic information. But now what we want to do, instead of sending like an H or an L based on like, hey, what, some square, mouse over a square, what we want to do is grab information from the internet and send that to the Arduino. Okay, so how are we going to do that? All right, well, what we're going to do is we're going to reach out and connect to an API. So that is an application programming interface. You've probably heard of APIs before, or at least in passing, but basically it's a way for organizations or companies or whatever to expose information in a database so that you can use it, publicly. So you might think of like Google Maps, right? Google Maps has an API so that other applications can basically point to that API or grab from that API and then implement those Google Maps inside their app. Or think of weather, right? Like there's all different types of applications out there that show you weather, but they're all probably getting their information from, different weather APIs out there. They're actually pulling down the actual forecasts from some API like NOAA, for example. So that's what we're going to do.